Okay, 6.4, Applications of Linear Systems. Number 1 says a bicycle store costs $4,200 per month to operate. The store pays an average of $65 per bike. The average selling price of each bike is $125. How many bicycles must the store sell each month to break even? So let's see. So we have two sets of information. We have overhead and expenses and income that we're earning. So let's have X represent the number of bikes sold, and let's have Y equaling the number of dollars of expenses or income. So my first equation we're going to make is going to be my expenses. Now, the store costs $4,200 per month to operate, and the store has to pay an average of $65 per bike. Now, if per bike is going to be X, we can have Y equals 4,200 plus 65 per bike. Now, my second equation is going to be what I'm earning. Now, the selling price of each bike is $125, so my income Y is going to equal 125 times the number of bikes sold. So these are my two equations. Now it's asking you how many bikes must the store sell each month to break even. Whenever you're asked to see when something's equal, the same, or when something breaks even, it means you got to set them equal to each other. So we have 4,200 plus 65x equals 125x. Now we just subtract 65 from both sides, and we get 4,200 equals 60x. Then we divide by 60, and we get x equals 70. So putting it inside for MathXL, we put in 70 because remember, x is the amount of bikes sold, and that's how much we need to sell to break even. So that is number 1. Okay, number 2. An investor invested a total of $3,100 in two mutual funds. One fund earned a 6% profit, while the other earned a 2% profit. If the investor's total profit was $126, how much was invested in each mutual fund? All right, so let's see. First, let's establish X and Y. Let's have X equaling the amount invested at 6% and Y the amount invested at 2% because we have two different amounts going on. So if you have a total invested at 3,100, then we know the amount of X plus the amount of Y equals 3,100. Now for my second equation, we have a profit of $126. It costs or earns 6% for each for X and 2% for Y. Turning the percents into decimals, I move the decimal point to the left two places, so I'll have 0.06 for 6% and 0.02 for 2%. So 0.06x plus 0.02y equals 126, since that's our profit. But now we go ahead and solve the system. So I'm going to go by solving by substitution, and I'm going to solve for x. So I'll subtract y on both sides, and I'll get x equals 3,100 minus y. You could have solved for y and gotten the same answers at the end. So now what I'm going to do is I need to substitute 3,100 minus y in for x. So I'm going to take the x out and replace it with that. So I have 0.06 times 3,100 minus y. So distributing that, 0.06 times 3,100 is 186, and 0.06 times negative y is negative 0.06y, then plus 0.02y equals 2. Combining my like terms here, I'll have negative 0.04y. So 186 minus 0.04y equals 126. I'll now subtract 186 from both sides, and I'll get negative 0.04y equals negative 60. Divide both sides by negative 0.04, and I'll get y equals 1,500. So now to find x, I will substitute that in for my first equation, x plus y equals 3,100. So x plus 1,500 equals 3,100. Subtract 1,500 on both sides, I'll get x equals 1,600. Now, remember what we're looking for is the amount invested in the mutual fund for 6%, and and the 6% is what x equals, so we will put in 1600 here. And then the 2% will be the 1500, so be careful you don't put these in the wrong spots. And that is number 2. Okay, number 3. A traveler is walking on a moving walkway in an airport. The traveler must walk back on the walkway to get a bag he forgot. The traveler's ground speed is 2 feet per second against the walkway and 8 feet per second with the walkway. What is the traveler's speed off the walkway, and what is the speed of the moving walkway? So let's see. Okay, so first thing we need to do is set up our variables. Let's have t equaling the traveler's speed off the walkway, and let's have w represent the speed of the walkway itself. So t and w. So if I'm traveling with the walkway, then I will be adding up my speed. So t plus w would be with the walkway. If I'm going against it, I will be subtracting my speeds because I'm working against it. So t minus w is against it. So the ground speed with the walkway is t plus w, and the ground speed against the walkway is t minus w. So we're told with the walkway is 8 feet per second. So t plus w will be 8, and t minus w will equal 2. So now that's my two equations. Now I can simply use elimination in this case, since I have a pair of variables with the same number but different signs, the w's. So let's add up. T plus t is 2t, 8 plus 2 is 10. Now I divide both sides by 2, and t equals 5. Now I can find out what w equals, replace t with 5, subtract both sides by 5, and w equals 3. Now remember, t is the traveler's speed off the walkway, and w is the speed of the moving walkway. It first wants the speed off the walkway. That would be t, so we need t being 5. Now the speed of the walkway itself would be 3 feet per second. So this is why you need to remember which is which, because we don't want to get them backwards. And that's number 3. So number 4 is actually a lot like number 3, which you'll see when we go through it. So if a plane can travel 480 miles per hour with the wind and 400 miles per hour against the wind, find the speed of the wind and the speed of the plane in still air. So let's take a look. Okay, so we need to set up our variables first. We have x equaling the speed of the plane in still air and y equaling the speed of the wind. So we have two different speeds going on. Now, when we're going with the wind, you will be adding up your speeds. When you're going against the wind, they're competing, so you will be subtracting them. Okay, so now our miles per hour for with the wind is 480, so we have x plus y equaling 480. We have x minus y equaling 400 when you're going against the wind, and then we can solve our system using those two equations. Alright, so looking at these, I see I have a pair of variables with the same number, just different signs, so that tells me I want to use elimination to solve this. So what I would do then is add them together. So x plus x is 2x, and 480 plus 400 is 880. Divide both sides by 2, I'll get x equals 400. So now to find y, I can just substitute that in for x. So 440 plus y equals 480. Subtract 440 from both sides, I'll get y equals 40. Okay, so now remember, x is the speed of the plane in still air, and y is the speed of the wind. So what we want first is the speed of the wind, so that's going to be y, and that is 40. And the speed of the plane in still air is going to be 440 miles per hour.